Hi everyone. Today's topic is about pointers and memory management. So the subtopic of this is pointers. We'll see what pointers are and what are the common mistakes people do while using the pointers, how they assume the things um, and do the wrong assignments to the pointers, and how these pointers are used in arrays, and how these pointers are used in functions, and how a pointer is pointing to another pointer, and some dynamic memory allocations like malloc, calloc, realloc, and free. How we have to use these memory allocations dynamically, make use of varied varieties of memory allocations, as well as how to release them once our task is completed. Let's start. First of all, before jumping into the pointer, we should know a prerequisite, which is address in C. The name itself, address, tells that the location, memory location, the particular variable. If we consider a variable var in our program, ampersand var will give you its address of the memory location. So why we have to deal with memory location in the first place? Memory location is much important because when you want to store a variable, process a variable across the program, we need to define a particular memory location where in which it is stored, and what is the size of that, and how this data gets pre and post processed during our program till the end of the program. That is the reason we need this address to be used across the C program. And one more way to use it is, if you remember in my previous sessions, we used a scanf function. In that scanf function also, when the user inputs the values, we used to take them using an address ampersand while considering the value from the user, where the value entered by the user is stored in this address of that particular variable. A sample output of it is, if you see the left side of the slide, you have a program which tells the usage of address. So here we initialized a variable var with 5, and we are printing it. What is a variable value? And we are printing the address of that particular variable as well using ampersand var. So that if you see the output of it, right, var variable is holding 5. Address of that var variable is some memory location address, some number. That number represents the memory location where this 5 is stored in your machine or laptop or wherever you run the code. One question will arise for everyone. Is this number is common, or is this number um, is static? This number is not common. This number is not static. This gets allocated dynamically whenever we run the code. If you run the code multiple times, this allocation gets changed with respect to the time. So we have to make sure that value is not changing, but address of it gets changed. So while running the C program allocates the size of the address of the variable as per the data type. In this code program, we have considered a var variable var data type of it is integer. So 4 bytes of data gets allocated in the memory. That address starting position is this value. Next, going to the next, we understood what is address. Now let's start with pointers. The pointer in a C language is a variable which stores the address of another variable. Very simple. I will repeat it. Variable pointer is a variable which stores the address of another variable. That means, let's say take you have an example here, int n is equal to 10. Now what pointer will does is pointer acts as a variable which stores the address of the another variable. Now here n is equal to 10 is a variable. N is a variable, right? That n address will be pointed by this pointer variable star p. This variable p of type pointer is pointing to the address of the variable n of type integer. Now if you print star p, you'll get the value, the address of that particular n, not the value of n. Very important thing. Okay. This variable can be type integer, character, array, function, or another pointer. So a pointer can point to these types. Either it can point to an integer, either it can point to a character, or it can point to an array, or it can point to another function as well. It can point to another pointer as well. Now, is this pointer has a defined size like integer? Integer has having 4 bytes, right? Now, how the pointer size will determine? The pointer size depends on the architecture of the machine. Let's say you are using 16-bit architecture processor in your laptop. Then size gets allocated based on the address with 16-bit. If you are using 32-bit processor, then 32-bit address gets allocated. The architecture will vary with respect to what processor you are using. Now in 32-bit architecture, the size of the pointer is 2 bytes. In 64-bit architecture, size of the pointer is 4 bytes. Example. Now we have to understand how to declare a pointer. The pointer in C language can be declared using star, which is also called as asterisk. The symbol asterisk. It is also known as indirection pointer used to dereference a pointer. What is meant by dereferencing? Dereferencing is nothing but if you are referring something to the point, that pointing to another pointer is called dereferencing. Example, you consider A, B, C, 3 variables. Now you create a relationship between A and B. Now B is having a relationship with A. Now there is another person which is C, that C is having a relationship with B. Now indirectly C will have relationship with A as well, because B is having relationship with A, so C will also have relationship with A. That process is called dereferencing. Referencing to the original value without having direct link is called dereferencing. We have assigned address to C as PC pointer. If you consider this particular program, so PC is equal to ampersand C. But that means C is equal to 5. We have assigned with 5. But PC is a pointer, right? Now this pointer is having address of another variable. As we studied the definition, it just always points the address of another variable. Now, in the next thing, the C value gets changed to 1. C value gets changed to 1. Now, if you print the value of C, the C value will be assigned with a new value, which is 1. But if you see the pointer reference, which is PC, if you want to access the value of PC, it also outputs to the value 1. The reason for that is, even though we have assigned to 1, the address of pointing the pointer is same. Even though you update to any value in that particular address, it doesn't matter to the pointer. Pointer always checks that particular address location. Whatever value present in that location, it doesn't matter. You update 5, you update after 10 instructions 10, or after some time 20, after some time 30. If you read at that point of time the pointer value, it will give you the latest value that is present in that address location. Very simple. If you assign a value to C is equal to 1, that means the pointer will update to 1, because the pointer doesn't care about the value, it care about the address. That is the reason, that is a powerful thing in the pointer. Even though you change the value to n number of times, still it holds the address of the memory location, right? That is the reason it holds the latest value. Now, what are the common mistakes people do in pointers? So if you see the left side of the code, in C comma asterisk PC. Now here I have defined C comma asterisk PC. C is a variable, asterisk PC is called pointer, right? Now PC is the address, but C is not. Why? PC is holds the address of the variable, not the value of the variable, name of the variable. That's the reason. So PC is equal to C is wrong. PC is equal to ampersand C is correct. That is the one mistake people use. Next one is ampersand C is address, but star PC is not. So second type is also wrong, right? Star PC is equal to ampersand C. That is also wrong. Now both PC and ampersand C is also wrong. Both C and star PC also right. Correct. So the right way of doing addressing the data is PC is equal to ampersand C, or star PC is equal to C. That means the pointer, whatever you have declared, that points to the address of another variable, or the pointer is directly mapped to the pointer value. So the right side of the slide, you have a function, int main function, C is equal to 5, star P is equal to ampersand C. So you are assigning address to a pointer, but it is dereferencing the value to the pointer, as I said previously. Now, if you print it, what you will get? You'll get 5, because star P holds the memory location. Doesn't care whether it has 5 or 10 or something. Just prints whatever there inside it. If you want to print the value, then you have to use star P. If you want to print the address, just use P. Next is pointers and arrays. How you have to use pointers in arrays. Array is nothing but, in previous uh, session we have seen array, right? Array is nothing but it has a maximum size. It will have unique data sets. If you consider it as integer array, then integers will be there in curly braces. Now, in this program, you consider a array X of size 5, which is having 1, 2, 3, 4, 5. Now I am having in another pointer int asterisk ptr. Now what will happen? Ptr is equal to ampersand of x of 2. I am assigning the address of second index of the array element. This is how you have to assign to a pointer. Now pointer will have a link for the second element present in the array. So that is index number, okay? Second index number present in the array. Now if you print the star pointer, then what will happen? It will print the second index element is 3, right? So it will print 3. So if you want to print the next element of it, you just increase the pointer plus 1. What will happen? The memory location gets incremented by 1 byte again. That is the next pointer will points to the next value in the array, which is 4. If you see -1, then what will happen? The address location will point to the previous value of the current pointer, which is from 3 to 2 it points. And this is how we have to write pointers in arrays. So the pointer, initial pointer is star ptr, that assignment. Now previous pointer will be ptr plus 1 whole asterisk, ptr minus 1 whole asterisk. This is how you will point to the previous and next member in the array. And how to use the pointer in array? This is how you have to use the pointer in array. Pointer points to the address of the particular index element in the array. Very simple. Next one is pointers and functions. How we can use the pointer in functions. So if you see here, left side of the slide. So we are having /include stdio.h header file inclusion. Next, declaring one function void swap. It takes to void is a null. That means it doesn't return anything. Just perform the instructions inside the function. That is why we have used a keyword void before the function. The function name is swap. What it does, it swaps from one element to the another element value. Now it takes two arguments. The argument one is n1, another argument is n2. But these n1 and n2 are normal, not a normal variables. These are the pointers. Pointers of data type integer. So the first one is integer asterisk n1, comma integer asterisk n2. This is a function. This is the function definition actually. This is not the original function. Original function will be written down. Now we'll go with the int main function. Inside int main function, int n number 1 is equal to 5, number 2 is equal to 10. That means we have taken two variables and values are also assigned to those variables. Now we are calling the function swap function. So I am passing the address of first variable and second variable. As the pointer, the swap function accepts the argument as a pointer, we have to pass address of the variable, not the variable itself. Reason to it is if you pass the variable, just the variable without address, then it points to the pointer points to the address, not to the value. I want the number gets swapped between the values, not the addresses get swapped, right? That is the reason here I have passed ampersand number 1, comma, ampersand number 2, swap function. Once that is called, the compiler will jump from here to the function swap. So the function definition is present over here, right? So it goes inside. Before going inside, whatever the values we are passing as the argument of this function will holds good and assigned to these pointers. Okay. So integer n1 pointer, comma, integer n2 pointer. These pointers are integer data type. So if you consider what is the job of this function? This function is to swap between the two numbers. Whatever numbers they are passing, number 1 and number 2. So number 1 value should swap with number 2. For that purpose, we can take one temporary variable into temporary. The temporary variable first holds the value of the first pointer. Then we update the first pointer values address with second pointer values address. Then the second pointer value address with the first pointer value address, which is stored already in temporary variable temp. Right? As we are dealing with address allocation mapping swaps, so original values will not get affected. It's just the addresses changing. That means initially the pointer 1 is pointing to one memory location. Like here we are having two memory location 1 and memory location 2. Now initially the values are same. Initially it is pointing to this location. Initially now I am changing, I'm swapping the memory location with this. That's it. I'm not assigning any value to this pointer. I'm just swapping the addresses so that once this function gets executed, these addresses will change. Initially, it is before executing this function, it is seeing or accessing this address. But after executing the function, the access will go to this address for n1 and this address for n2. Okay. This is how the swap function will work. When you run the code printf with number 1 and number 2, initially it has 5 and 10. Now it will have 10 and 5. This is one way to do it. Now the next one, another example we'll see. How to use pointers in the functions. Okay. Now what we are doing here is again /include stdio.h and function type is void. That means it won't return anything. The function name is add1. Add1 means whatever the value the argument is having, for that value I will just add by 1. So what is argument? Argument is in the form of pointer. Data type of that pointer is integer and the name of it is asterisk ptr. This is the pointer. In that, the instruction I have given here is asterisk ptr plus plus. What is meant by this? It's a post increment. Whatever the argument is passing, to that I am adding 1 to that pointer. This is nothing but ptr plus ptr is equal to ptr. ptr is equal to ptr plus 1. Now going to the main function. In this main function, we are declaring a data type of integer pointer, comma, another variable I. Now I is equal to 10. We are assigning to the value 10. Now P. P is nothing but a pointer which has the address of the variable. Here my variable is I. Ampersand I is the address. So I holds 10. So this memory location is holding 10. This is pointing with P pointer. Now I will pass this. I'll call the function add one function and pass the argument P to it. What kind of argument this function takes? If you go from here to here, the function call, it takes only the integer pointer. This integer pointer will accept as P, not star P. The reason is we are given here P is equal to ampersand I. This is one way of doing, or else you can do one more here. Int P, comma, I is equal to 10. I, if you declare like this, and now you have to do like this, star P, asterisk P is equal to just I. Then you can pass here in the argument of the function asterisk P. So it will consider the value and add 1 to the value. It increments the passed value with 1. This is how it works. So once you print the value after execution of this function pointer, then it changes the value to 11. So here, at this step, the value goes to 11. As this is written as integer data type, we have to give written as 0. Hope this is clear. Next one is pointers to another pointer. This is a common usage in industry, and most of the questions will be asking in interviews how this will be used. Now slash include stdio.h header file. Inside the main function, I am considering it here 3 variables. First variable is number integer is equal to 10. Next is another pointer which is star ptr. Next is double asterisk ptr to ptr, another variable. What will happen here is, now initially I have taken ptr. ptr is a pointer which always assign with address of another variable. Our variable is number, right? Num. So address of another variable only it will hold. So now ptr is equal to address of that particular variable. Now what will happen here is the address of this number is held by this pointer. Next one is I am having another pointer declaration, right? This is another pointer ptr to ptr. Now ptr to ptr, I will assign address of another pointer. This is like you have an address here. You have an address here. Let's say you have address here. Now you are having referencing one pointer here. That is P. P. P1 is the first pointer. Now what you're doing is you are referencing another pointer to the first pointer, which is P2. Now what will happen? Let's say here initially it is having 1 in the data. Now P1 holds, the pointer 1 holds 1. Now P2 holds the address of the first pointer, right? And indirectly P1 holds the address of this pointer. Now what will happen? This P2 holds the value indirectly with this value. Okay. As it is not directly accessing this address, but this pointer is accessing the address of this, but this pointer is already linked with this address. So whatever there here 1, here also it will be 1. So whatever there here gets updated over here. Now, if you print that, you will get in our program code, we are having giving with this 10. Now, if you print the star PTR, which is pointer value, not the address, okay? Pointer value asterisk PTR. So it gives and prints the value as 10. That's why the value of number Here given after execution of this instruction, you are getting 10. Now, if you print the pointer to the pointer, again, as this is holding 10, so P1 holds 10. Again, pointer 2 holds the pointer 1 value, right? So that is also having 10 here. So that is the reason you will get 10. Now let's say you modify the value pointer to 20. Now what is meant by that? You have changed the value to 20. What is meant by that? If you change the value to 20 means you are indirectly changing the value in the address location of 20 only, right? So if you change here, it gets appended over here again. Then it gets appended over here. If you print the variable this is the number, right? First number. Then it will hold 20 again. This is called pointer pointing to another pointer. So here sometimes what problem may arise is if you are pointing to the declared value of another pointer, then you will get the answer and you will get the right value. Let's say you are pointing to a pointer where it has nothing. It just has junk value or anonymous value or a void value. Then that pointer points to nothing. Which pointer is pointing to the another pointer, then that is also having the ambiguous value. So that state is called dangling pointer, which is holding void of void. So if you print the dangling pointer, second pointer, then you will get a junk value that is getting printed. Next is DMA. DMA is nothing but dynamic memory allocation. So what is meant by dynamic memory allocation? The name itself says that it allocates memory dynamically whenever it is needed. That means, let's say you are having a memory that is there in the stack pointer. Okay. In this stack, you have, let's say, 400 bytes of memory. But when you are executing the code, you have declared an integer variable of four integer variables. So that means each integer variable will hold 4 bytes of data. Then 4 integer variables will hold total 16 bytes of data. And you started writing code in several instructions. After writing 20 lines of code, you have reached that, and you have reached to a situation where this 16 bytes of data is not sufficient. Now, after that, you cannot go back and update or change the value, because you don't know, right, whether how much size of the data is needed. If you use double also, double will hold how much? It just hold 8 bytes of data. If your data or your processing needs more than 8 bytes, sometimes it needs more than 8 bytes, sometimes it needs less than 8 bytes, or some less than 8 bytes is okay. Double you have given, so size will be getting accumulated. But what if the size is more and it is not predicted also? Then this DMA will help us to, make use of memory location promptly instead of getting an errors. Error like memory out of range, this kind of error. Now let us understand what is this DMA. Hope you understood what is DMA, but we will see where and when, what type of categories are present in DMA. First of all, if you consider an array, it will have fixed number of values collection. If you declared an array once, the size of it is, if it is declared at the start of the program, during end of the program, entire cycle of the program, the size of an array cannot be changed, right? As this is a stringent to the size that you have mentioned. If you are declaring an integer array or a character array, then that particular size only get accumulated or allocated in your memory location. Sometimes what will happen is the size of the array, whatever you have declared initially, may not be sufficient. As I told you, it will vary. If it going beyond your expectation or beyond your calculation, then code won't get executed. It will throw you the memory allocation errors. Then this is a critical problem, right? How to solve this problem, and how a person can, a coder can, a programmer can, predict the amount of allocation. He cannot, right? So to solve this problem, we came up with DMA. What it does is we can allocate a memory manually during runtime, which means once the code is running, it will allocate the extra memory that is needed during this runtime itself. This is known as dynamic allocation, memory allocation in C programming, and it is very powerful. Again, powerful things come with greater responsibilities. If you are not using the right way of using this DMA, it will create proper thing, like it will create allocate memory for you. But if you are not accessing or not properly using this DMA, this will also create a flaws to your coding. Let's say you are continuously using all the memory, then what will happen? All the memories get allocated to your program, and there is no memory to run the program itself. The processor get dangled, and the process cannot further process the code, and it gets stopped as well. It get halted as well. So that type of situation can also be erased. So let's see how to allocate these dynamic memory allocations. Is there any internal functions that are being there present? Yes, of course. It has. It has four different types of inbuilt functions. One is malloc, second one is calloc, third one is realloc, next one is free. These functions are defined in standard library.h. stdlib is a header file function which you have to specify in the inclusion list section of the coding before accessing these functions. If you are not keeping this header file and using malloc in your code, then it will throw error. Definition not found, because the definition is present in stdlib.h. So you have to mention in the inclusion list of your program. Let's understand what is malloc. The name malloc stands for memory allocation. That is a full definition of malloc. M-A-L-L-O-C. M refers the memory, ALLOC refers the allocation. If you want runtime memory allocation, then your first go is to use this malloc function. This malloc function, what it does is it reserves the blocks of memory of the specified number of bytes. You have to specifically tell you need these many bytes of memory that needs to be allocated during runtime. That type of memory can be dynamic or can be static also. If you are clear with how many bytes of data is needed, then you can mention a static number, or else you can use a dynamic number. You can use a dynamic number. Okay. Now for the static number, right? Most of the codes are good practices, right? Mentioning the static number is not the right way. This leads to memory expansion as well. Now what will happen? Let's say you want just 4 bytes and you are very sure that you want 4 bytes. If you for down the lane when you wrote the code, you expected that your requirement is strictly 4 bytes. But down the lane, when there is a exceptional case, a user has entered something that leads to create a 5 bytes of data, right? So which is not expected from you. You have, while coding, you have not thought about that particular corner case. Then your code will fail in that situation. So the best practice is use dynamic allocation while processing your data. So this returns a pointer of void which can be casted into the pointer of any form. The syntax for malloc is the pointer is equal to cast type pointer and malloc of size. Malloc takes an argument which is the size that is needed, the dynamic size that is needed. If you are very sure of your size, then enter pass the argument with the needed size as a static data. If you don't know, then pass a variable, whatever the size, it gets updated during your code execution. One such example is, if you see, right, the pointer is equal to float star malloc 100 into size of float. So here it is very clear. In this statement, it allocates 400 bytes of memory. Why 400? The size of float is 4 bytes. And we are multiplying size of is a inbuilt function which calculates the size of the float, whatever passed data type. So here passed data by type is float. Size of float is 4 bytes. We know that 4 into 100 is 400 bytes. You are passing as an argument to malloc. That means 400 bytes. You are asking malloc to create a dynamic allocation in the memory. Because the size of float is 4 and the pointer holds the address of first byte of the allocated memory to the 400 bytes of allocated memory. Now what will happen is there are two conditions. If here you are having 400 bytes of memory that is already free in your machine wherever you are running the code. If it is free, then very good. This particular instruction gets executed and you will get the address of it because PTR is equal to address of the particular position. The pointer always pointer to the address of the location. Now, this is a positive case. Negative case is you don't have that amount of allocation available in your memory. That means here I have given 400 bytes. You don't have 400 bytes enough space in your memory. Then what will happen is it returns this pointer will points to the null location, which is a void location, which means we have to understand that there is an error which has been erased due to insufficient of memory. That is the reason this pointer will points to the null pointer location once if it is not able to allocate the memory. Next function is calloc. So this is the name calloc stands for contiguous allocation. C stands for contiguous and alloc stands for allocation. What it does is this malloc function allocates the memory and leaves the memory uninitialized, right? So it just creates a memory allocation and it just creates show you the pointer position. Whereas calloc, what it does is it allocates the memory and initialize with all bits to 0. That is calloc does. So in malloc situation, it allocates the memory if memory is sufficiently present for your for your application. Then it will provide you the address of the particular start address and end address. But that address may have a junk values also, a void referenced values or junk values also. But in calloc, you have specifically instructed that you need a filled data, not with some random or junked values. If you want your application to be dynamically allocated with zeros for these allocated addresses of memory location, then you have to use calloc. The syntax for that is the pointer is equal to cast type asterisk calloc of n comma size. These are the two parameters which will be taken as arguments to the calloc. Now we will get a question, what is n and what is size? N is nothing but number, size is nothing but size of each number. Let's say in previous example, we have used here size of float. Means the float is the size. Here we'll call it as n. And the size is 100 location. The same way. Now here the size n is how many memory locations I need. I need 100 memory location. 100 memory locations. Of each memory location, what size you want? I want, let's say, 6 bytes of each memory location. I have to write 6. Now, what will happen? 100 memory locations get assigned with into each of 6 bytes, which is equal to 600 memory locations of each of data zeros. Each bytes of data with zeros get accumulated in your memory location of this 600 bytes of data. Some example of calloc is allocates contiguous space in memory, right? You see this pointer is equal to, what is the typecast? Your typecast is float because you are saying here float. Now calloc of 25. So 25 element memory locations of each of size of float. So you are saying the size is float and how many locations you need? 25 locations you need. So what will happen? 25 into size of float is 4, right? So which is 4. So that means 25 into 4, which is 100 bytes of data which gets allocated all with 0. Now we are continuously allocating. But what is the best practice? If you run a program, if you write a program or while running a program, you don't know how much memory is needed. That is the reason you are using these DMA concepts. Now what will happen is, if you continuously allocate the initializations or allocate the memory locations with 0 using malloc and calloc. Now, once you end the program, what will happen? These memory locations are fixed and cached with this malloc and calloc pointers. Unless you free up that memory location, it will always creates these pointer references in the memory. So which is not correct. Let's say you are running 10 or 20 different types of programs in the machine which uses DMA, in it. Now at that point of time, if you are not freeing up this and using more and more and more amount of data which is getting accumulated or holding by these pointers of malloc and calloc in all these programs, then what will happen? You won't have enough sufficient of memories that gets accumulated or hold. Then this will leads to a bigger thing called mishandling the memory locations, right? Because what will happen? If you run the next program, the first program you ran, you have allocated 1000 bytes of data using malloc. Now that particular pointer will points the 1000 bytes of data entirely. When you run the second program, again 200 bytes of data gets accumulated. Third program, third point. Now these three programs will have three different pointers which accumulated 600 bytes of data. In this 600 bytes of data, these three pointers will be pointing to each of them. Now there is no extra space that is present in your memory. What happen if you run the fourth one? It won't handle. It will throw you error. Memory exception erased. Because have invoked these memory locations with pointing to these pointers, but you have not freed up that memory locations anywhere in the code. That is the reason you are getting these handling exception. So what is the best practice? The best practice here is whenever you are using malloc or calloc, simultaneously you have to use free function. A free function is also an inbuilt function for this DMA. What does this do? This dynamically allocated memory created with either calloc or malloc. If you want to free up this allocation pointers, then you have to use this function free. What it does, whenever you pass a pointer argument to this free function, this freed up the allocated memory dynamically. So the syntax for this is free. Argument of it is whatever the pointer that is allocated dynamically, the same pointer variable you have to pass here. Next one is reallocation. Realloc. The dynamically allocated memory is insufficient. You have initially allocated a dynamic memory using malloc or calloc. Now that is also not sufficient. Then if you need more than that, then what you have to do, you can change the size of the previous allocated memory using realloc function. Let's say initially you have given with 100 bytes of data. That is also not sufficient. You have interpreted that you need more than 100 bytes of data while coding. At the end of the program, you felt that that particular value is not sufficient. Then what you have to do is you have to change this allocation. Instead of going back to the particular line and change the malloc or calloc, you have special function like reallocation. It just allocates the extra memory that is needed from the pointer where it started the allocation. Here the pointer is reallocated with the new size. Initially it has 100, now you need 200. This 200 bytes of data gets allocated with this new pointer. Pointer name is same again. Allocation is also same, but the size of it is varying. Initially it will the pointer points to 100 memory locations. Now it points to 200 memory locations. Very simple. The syntax of it is pointer is equal to realloc of pointer comma x. So pointer is the previously allocated pointer using malloc or calloc, that pointer, comma, the new size, how much size you want, that you have to keep. This is the syntax for realloc. Let's see some examples from here. DMA, everybody will say about DMA and they can explain. But while writing the code, it becomes challenging. One such example is this one. I have used here reloc. So as I said, this, if you want to use DMA function, you have to include standard library.h, stdlib.h. Now in the main function, I have used a pointer one, I, n1, n2. These are the three variables, and one pointer initialized. All these are data type is integer. Now I'm asking user to enter size. Size of it is 2. He entered 2. I am scanning and storing that value in n1. Now user needs 2 bytes of data extra. Now what I will do, I know the fixed size. User entered the fixed size. So he doesn't need any fixed allocation with fixed values like zeros, which is calloc. He needs just fixed allocation. That's it. Whatever values it is pointing, he doesn't care about it. So I will use now malloc. What is malloc? What is the syntax for it? Syntax for it is data type, typecaster, which is int star, and malloc, and argument is the size. Here the size is the mentioned size into size of the data type. So the data type here is all the data types are integer, right? So I'm considering here integer. Now what will happen? Now it will show you the addresses of asked size, which is size 1 and size 2. These are the two addresses. How I am printing? I am using a for loop. I is equal to 0, I less than n1, and pre-incrementing the address before iteration. I am printing that with printing the pointer 1 and pointer 2 initially. Now user has another need. He wants to reallocate the allocated memory, increase the allocated memory. Now we will ask the user that what is a new size that you want to expand. So he enters here 4. Now we have to increase the size by pointing the same pointer value. So how we can do it? So the syntax for that is realloc and initial pointer. Initial pointer is PTR. This is the extra allocated memory. That PTR, I have to give argument as PTR, comma, the new size of how many size, how many extra size you need. That extra size is n2, where user input is getting stored. That n2 into what is the data type size? Data type size again it is an integer, right? So I've taken the size of it. Now I will print the newer list. If you print the newer list, what will happen if you see, right? The first one, second one is the same like previously, 7276. Now third and fourth is the appended data, next new size. The next new size of it is 4 bytes. So the total, initially his requirement is 2, user requirement. Now with the new requirement, it changed from 2 to 4. Okay, that is the reason it got changed. So this is how you have to use malloc and realloc dynamically in a program. Now example for malloc and free. In previous example, right, I just allocated the data. I didn't freed up. If you see at the end, right, I have used here freeing the pointer. This in the given problem statement, it didn't ask me for free up. But as a coder, the good practice is whenever you use malloc, reloc, and DMA functions, you have to always use a free method or a function to free up the allocated memory location pointer. So allocated memory location pointer is PTR. That pointer I will park as an argument and free up that particular memory location. Next one is malloc and free. The same way, I have taken n and I integer variables and pointer ptr, and sum is equal to 0. Now I'll ask user to enter how many numbers he want to enter. The number of elements is he is entering 3. Now I will see and allocate the size as per his need. He says he wants 3 bytes of data. 3 times of bytes of data. So 3 into the size of it is integer. As I have taken everything is integer, so I have taken integer. Here we have to do the exceptional case also. As I said, if you don't have memory also, then what will happen? It if you are not handling that exception, then you will get a memory allocation exception error. So you should be very much prompt to implement this particular code whenever you are writing C. This particular code is if your allocation pointer, as I told you, right, malloc, if it able to allocate, it will give you the address of this pointer. If it is not able to allocate, then it gives the null pointer, void pointer or null pointer. So whatever allocated after that, if you compare that particular pointer is null, then what will happen? Memory allocation is not allocated because it doesn't have freedom allocation available. And you are doing exit 0. Exit 0 is nothing but once it hits here, it won't further process the code instruction. After that, here we have memory allocation and pointer is having address of the variable. It's not a null pointer. Okay. Now we'll ask user to enter these elements. He entered 100, 20, and 36. So all the 3 elements were entered by the user. So one by one, we are scanning and storing these values in these allocated memory address one by one. How we are doing it is using a for loop. I is equal to 0, I less than n, and plus plus I is a pre-increment of I. Why we have taken n? Because n is a required amount of size user will enter. That is the initial input he has given to us. That is the reason. And every value I will store in the memory location. Now after storing what I'm doing, I am taken a variable, another variable, sum is equal to 0, right? Initialized with 0. This sum I am incrementing. Sum is equal to sum plus the pointer address. That's it. The pointer address is this. As it is a pre-increment, I will add plus I also to here. So that it will point from 0 to the rest of the pointer. Once that is done, this for loop is iterated with the number of elements the user has inputted. After that, I will print the sum. So printf of sum is this. So I got whatever sum value over here that gets printed here. So once this printed, you will get the value here. So your application and operation is completed. Now what is the best practice? Whatever allocated memory is there, that you have to free up. So using free, I have to free up the pointer. This is how you'll use a malloc and free together, and the right exceptional handling also is there. So it's a good practice of writing the code. Next one is example for calloc and free. Now in this, what we are doing? We are having calloc. Calloc means we know user is asking to allocate a memory locations, extra memory locations dynamically with, instead of junk values, he is asking defaulted with zeros. That is the reason we use calloc here. Again, the same operations. I will ask the user how many elements are needed. He enters 3. Then instead of malloc, I will use here calloc. If I use calloc, what is the syntax? So typecasting, which is an integer typecasting we need, and calloc, and what is the size user is needed, that is n, and the data type of it. Data type of it is initially declared with integer. So I will pass size of integer. If it is able to allocate, well and good. The pointer will have address. If it is not able to allocate, it will have null pointer. So these three lines are mandatory to handle the error exception. If this pointer is null, then we will force exit here, stating that there is no further memory allocation will happen because memory is not free. All are occupied. Now, if you're not getting null pointer, if you're getting an address pointer to the pointing of this pointer, then you will ask user to enter the elements. So once this enter the elements option comes, user inputs. Initially, he wants to enter only 3. Now he will inputs 3 values, 100, 20, and 36. We have to store these 3 elements in a pointer address in the same way how we have done for malloc, in the same way for calloc. But what is the difference here? Previously for malloc, allocation is there, but it has allocated with some junk values. Here, allocation is there, but it has allocated with zeros. So now your values are being assigned to this memory location using this for loop. Once that is done, you will free up the memory by printing the values. That's it. So what is the best practice, sir? So we have to use malloc or calloc. That purely depends on your application. If your application or user who is asking you to develop the application, he doesn't want any junk values that has to be seen during his application running, then he strictly says that to use calloc. He is okay to see 0 at any point of time, but not the junk values. And the good practice in the industries is using calloc only, not malloc. But one disadvantage while using calloc is if you use calloc, the execution time gets increased than malloc. Reason for that is malloc, it just points to the allocated memory. But calloc has another task to perform. It points to the allocated memory plus clears the junk values and override that value with zeros. So this is another task that is overburdened to the calloc. That is the reason it takes more amount of time. So it depends on you and the requirement. If your requirement is okay with time constraint, then use calloc. If it is not okay with your time constraint and it needs a faster execution, then use malloc. Once that is done, you have to free up the mess. So that's all. I'll stop till here today. Thank you.